In part 2, we will be multiplying binomials by binomials. And so this is a big concept in algebra because we end up having to solve quadratics, which is what we're going to end up making here. Typically is a quadratic. Sometimes they're not. Some of these will not be quadratics, but we'll solve quadratics often by factoring. And factoring is the opposite of multiplying. It's kind of like dividing, opposite of multiplying. Somewhat similar concepts there. So the way we're going to end up solving this, or going and multiplying, is we're going to use this FOIL method. The FOIL method stands for the first and then the outer terms, and I'll go ahead and write it up here, FOIL. And so we have the first terms, and then we are going to add in the outside terms, or outer terms, plus the inner terms, and then add in the last terms as well. And so we're going to end up using this method to multiply, and then also when we get into factoring, we're going to use it as well. So the first terms are these. X times by x. It's the first two terms in each of the binomials. So those are our first terms. So we do x times by x. And then we move on to the outside terms. So we've multiplied x by x. Now we multiply x by 4. Those are the outside terms. So plus the outer terms. So plus x times by 4. Then we move on to the inside terms. Inside, well, we've multiplied x by each. Now we move to the 3. These are the inner terms right there. I for inner. So plus the inner terms. And those would be 3 times x. And then we do the last terms. So we do 3 times by the 4. Those are the last terms. So plus the L. And we write down 3 times by 4. So we go ahead and do that work. And here we have x times x is x squared. X times 4 is just 4x. We have 3 times x is 3x. And then 3 times 4 is 12. So there it is. Now we just collect these two terms. We're left with x squared plus 7x plus 12. And there would be our answer. Well, this one is very similar. It's just that it's x minus 6 quantity squared. So the common mistake is people want to square x and square 36 or square 6 and get 36. But that's not the case. What we have to do is write this out twice. X minus 6 times by x minus 6. And then we use that FOIL method. So let's practice that again. So our first terms are going to be the x times by the x. Those are the first terms. X times x. Then we move on from the x and multiply it by the negative 6. Those are the outside terms. So plus outer, so it's plus x times by negative 6. Now we move on to the inside terms. Negative 6 times by x, so plus the inside. Negative 6 times by x. Again, we've multiplied x by each, then that's why we moved on to the negative 6 in this case. So negative 6 times by the negative 6. So those are the last terms. So plus the negative 6 times negative 6. Well, from that point, what we do is just multiply. That's all it is. So x times x is x squared. We have a negative 6x, because it's a negative 6 times by positive x. Another negative 6x, because they're opposite in sign. Here it's a positive, because they're the same sign. So we go ahead and collect like terms. The two x terms there make a negative 12x. So x squared minus 12x plus 36 is our answer. Well, here's another one, a little different, because now we have a coefficient in front of one of these terms. So let's go ahead and try it. Remember, our first terms are 2x and x. Those are the first terms. 2x times by x. Then we move on to the outside terms. Outer terms here are 2x times 6. Notice again, you're multiplying 2x by both numbers inside the other set of parentheses. So the outside were plus 2x times by 6. So then we move on to the inside terms. Now we multiply the 5 by both numbers. So 5 times x, those are inside terms, so plus 5 times by x. And then we do 5 times by the 6. Those are the last terms. So plus the last terms which is 5 times 6. Well, you go ahead and do some multiplication, count up what you got left. Here, 2x and x makes 2x to the second. Remember, x times x makes x squared. 2x times 6 makes 12x, and a 5 times x makes 5x. And then we have plus 30. So we go ahead and collect some like terms right there, and those combine, and we're left now with a 2x squared, a plus 17x, plus 30. So the only difference between these next few problems is that the variables, there's different variables. Maybe there's more than one variable in a problem. So it's the same sort of thing, though. We're multiplying the m squared times the 5m. Those are our first terms. So the first terms here, m squared times by 5m. And we move on to the outside terms. So outside are m squared times by n. So plus m squared times by n. Well, once we've done multiplied the m squared by both, then we move on to the 3. So we do 3 times m. And that gives us our inside terms. And that would be a plus 3 times 5m. Then we multiply the 3 by the n. Those are the last terms. So plus our last terms, and that would end up being 3 times by n. And then from there, again, you're just multiplying the numbers, counting up the variables, how many there are. And that will tell us our exponent. So 5m to the third plus, and then we have m squared n. Can't do anything with those except just bring them next to each other. Times by 15m. Times, or no, I'm sorry, that's a plus there, plus because of the plus sign. So 15m, 3 times 5m makes 15m, and 3 times n just makes 3n. Now, you can't combine anything. They all have different exponents on the variables there, so that's as far as we can take it. Can't combine the m and the n because they're different terms. Well, one more like that. Let's take a look at this next one. It has an a squared and an a. Those are our first terms. So we'll write down f for the first terms. And let's see if we can do this without having to do this intermediate step here. A squared times a. That makes a to the third power. A squared and a to the first makes 3a's. Let's do our outside terms. Outside terms are the a squared and the b. These are outside terms. That makes a plus a squared b. You can't combine those because they have different variables. And then we move on to the inner terms. And the inner terms are when we're multiplying the b squared, in this case, by the a. So that makes a positive. Now I'm going to put the a term first. A, b squared. Typically we put the variable that comes first in the alphabet first. Just like in descending order, we always typically look at the variable that comes first in the alphabet with those exponents. So those are the inner terms. Now it's b squared times b for the last term. So plus, and that would make b to the third power. And that's it. You can't combine these because they have different exponents on the variables there. Can't combine a squared and b and a b squared because here the a is squared, here the b is squared. Well, we got a word problem here. Here they're asking us to write an expression for the area of a rectangle. And so let's take a look at what we got. Typically we consider this side the base, or sometimes we call it the length, and then maybe this side here we'll call the width. So I'm going to read off what it says. The length of a rectangle is typically, it means equal. So let's think of it this way. L is, okay, length is equals 3 inches greater than the width. 3 inches greater. That means that if I have the width, I would add 3 inches to that. And that would give me the length of the rectangle. So instead of using L, let's just use this expression right here, W plus 3. All right, well now they want the area. Area is just length times by width. So what I'm going to do is I'm going to take this length, multiply it by the width, but in place of L, let's write the expression L is W plus 3. So that's what we'll write here, W plus 3 times by the width. Well, from there it's just a monomial times by a binomial. We're going to multiply the w by w, and that gives us w squared. And then I'm going to do w times by 3. That gives me 3w. And they say, let's see if they have units in here. Nope, no units here. So since we're dealing with an area, I'm going to write down units squared. So w squared plus 3w units squared. And what that does for us, if we knew what w was, then we could put that number into that formula and come up with the answer for the area. Well, those are some of the problems that you'll see on tonight's homework. Good luck.